All right, guys, it's 10:05. Welcome to today's webinar. Thank you very much for all of you who sent greetings to the chat. Joshua, I can see you. Michelle, I see you. Welcome, everyone. Welcome to today's webinar. Data2Bots Academy has been presenting a webinar series to you since the start of April 9th. And this is our third webinar, and we're glad to have every one of you here. So let's kick off into this webinar. For those of you who don't know, for those of you who are joining us newly today, Data2Bots is an IT consulting firm providing data engineering and data science related services all across Europe, and to companies that require this data engineering solutions or data related services to build data solutions. So we are a consulting company in the Netherlands and in Nigeria, and what we expertise on is providing data solutions to companies that need to drive data-driven decisions. Now, about the academy. The Data2Bots Academy is trying to bridge a gap between the supply and the demand of data talent. So Data2Bots Consulting, with all our years of experience and expertise, we have found out that there is a gap for the supply and the demand and the available demand to fill in that supply. So Data2Bots initiated a Data2Bots Academy that is going to serve as a starting point to create data talent that go out and add value in the data space, in the data world. And that is why we have this platform called Data2Bots Academy that will serve as a talent pipeline to upskill, train, and eventually place data talents across data roles in the data space across the globe. So what we have today, in the previous webinars, next slide please, Happiness. In the previous webinars, we have spoken about various things, and today we are going to dive into a very good fact. So our content lineup remains the same. We'll have our speaker give his speech, and we'll have a session for Q&A later. Next slide, please, Happiness. So today's webinar, we have seen various things in our previous webinar series. On the first webinar, we answered the question of why anyone would want to be a data professional. And all of those information is on our YouTube channel at Data2Bots on YouTube. Just search Data2Bots on YouTube and you'd find all those videos on our YouTube channel. So in our first webinar, we spoke about what are the things we require, like why would I want to become a data professional? And we answered those questions, giving you very serious concrete reasons, such as the global relocation opportunities that are available, the work flexibility, who a data professional is, and how a data professional acts and plays in the data value chain. Next, we didn't stop there. Next, we gave you reasons on what you require or steps on how to actually become a data professional. And today we are going to be discussing about how you can be a data engineer. Now we are going into data roles within the data space. These data roles, we have already told you from our previous webinar that we are going to be going into these data roles in depth. And now we are starting with the data engineer. And data engineering is something that's close to home, close to our hearts here at Data2Bots, because we offer data engineering services more than other services that we provide. So data engineering in the data space is what we are here to discuss about in today's webinar. And our speaker is going to be taking you on a very incredible journey. First of all, debunking the misconceptions about data engineering, explaining to us who a data engineer really is, explaining to us why a software engineer is not a data engineer, explaining to us the roadmap for data engineering and the skills to learn. I'm very sure a lot of people are waiting for that part because they're like, oh, how do I get started immediately? You're going to see a beautiful roadmap that we've designed on the steps that you can take to become a data professional, a data engineering professional through our roadmap. Now, he's also going to take you on how do you stand out from other data engineers when you've already entered this space, because this is the data space is a space that is people are rushing into. There is a lot of noise in it, and we're going to give you the actual tips on how you can exempt yourself or filter yourself from that noise. And now we are going to help you understand if data engineering is the right career for you. So a beautiful outline here. Now we're talking about data engineering in the data space. Next slide, please. And again, our speaker is Mr. Damilola Oke. Now I want to tell you this, guys. There is no better person I have met on planet Earth that would deliver this content to you today. Damilola Oke has years, decades plus experience of delivering actual data value to companies in Europe, in the Benelux region, companies like Philips, companies like Randstad, companies like CZ, companies like NNIP, just to name a few. And for today's topic, which is data engineering in the data space, there is no better person, I can guarantee you, this to give you this content. Damilola Oke has successfully trained, has successfully built data engineers that are delivering value in companies right now, like Nike, T-Mobile, and you're in the right place. Like, if I've not said this before, right now, you're in the right place because Damilola, the lead consulting engineer at Data2Bots Consulting, is going to deliver to us this content. So, Mr. Dami, I can't actually wait. Over to you, please, and let's get this started.
All right, thanks, Joshua, for that warm introduction, as usual. Thanks, our wonderful audience today, for giving time to listen to this. This webinar series is at the top of my heart, but today's topic and discussion is the one I love the most. And the reason is simple. It's that I have spent most of my life doing this every day. And when you spend your life doing something and you feel you are successful at it, the greatest joy is to share the same knowledge to people and give them the room to benefit from your wealth of experience. So, as Joshua has gone through the outlines for today's topic, the first thing I would like to do is to clear the misconception about data engineering. I've spoken to many professionals, many engineers, and I always ask, even at interviews, can you tell me what is data engineering? Data engineering has become something that most of us cannot even define, even us as data engineers. And the reason is simple. The reason is because it's a very broad area and it's very difficult to pin down what a data engineer does on a day-to-day basis. But as you can see, in the definition we gave, of course, we try to put some life into that definition. We basically use the illustration of what I call a teenage SEX. And the reason is simple. It's because it has become something, it becomes something everyone is talking about, okay, on a day-to-day basis. You hear it everywhere you go, even in the big companies, in the Fortune 500s, they're all saying, okay, oh, data engineering is this, data engineering is that. But the truth is that nobody really knows what data engineers do. okay? Because you cannot really pin it down. Everyone basically thinks everyone else is a data engineer. And so the point is that it has become a fluid area whereby people really are looking for the best way to define this. What I want to just highlight on here is that data engineering is not data science. Okay, data engineering is not using SQL, or better still, let me say, data engineering is not limited to using SQL. Data engineering, a data engineer is not a software engineer. Okay, and data engineering is actually a broad area that, because of how broad it is, other roles have been breaking out of it. Okay, now we see roles like analytics engineering, we see roles like data steward, all breaking out of data engineer. So new roles will keep breaking out because it has become so big, and what they do is really incredible. They are basically the guys that have come together to rescue us from this data explosion. So my next discussion would be, who really is this guy? You know, who really are these guys? Okay, so a data engineer builds the system and processes that enable the usability of data. For those people that have joined us in our previous webinar, you must have seen us go through the data value chain. Okay, saying, okay, there are several steps that several data actors had value within the data value chain. So this entire system that you see within that data value chain is built by data engineers. So they build that system. For you to add those values, somebody needs to build a process. And a good example would be, you have a new factory coming up. Okay, within this factory, you need machineries. You need people to come into the factory to build those machineries. When they are done, they could also be part of the actors within that are using these machineries, or they could just build the machineries and go. But who are these data engineers? You have a cashew farm that has been running for a couple of years. Now it's time to harvest, and they want to basically start creating cashew nuts. You call in your data engineers, they basically build the machineries, and they also teach you how to use it. And before they leave you, they also basically be part of your users so that you can feel comfortable. So this is where you need to see who data engineers are. I would now give it in a more IT perspective. Okay, what you see is that you've built this beautiful application, be it Facebook app, be it Instagram, be it some app for a bank in Nigeria or somewhere, whatever it is. You've built an app, it's live. You have users on this app. This app, users are performing several CRUD operations. What are CRUD operations? Create, read, update, and delete. These are the operations that happen on an app. So somebody comes into the app, creates an account, deletes its account, this person updates his profile, this person makes a purchase. They're performing several operations on this app. In the back end of things, you have a database, and within this database, several actions are happening. Okay, so as a business owner, or as an app owner, or as an investor, or a stakeholder in this app, in this service, okay, what happens is you want to know how users are using my app so I can make informed decision. What do I need to grow my users within this app? What don't users like? Why are users taking these actions over these actions? You cannot basically answer that by just having an app, okay? And there is no way you can do this better by bringing in a data engineer into your first data team, into your data team. That's going to be your first hire, basically. What is it going to do? What it wants to do basically is to build a system which starts from the extract system. Okay, this is the database. How can I extract? Or this is the application. Whether from the application perspective or from the database perspective, the point is you need to extract this information either periodically, which we call batch, or in real time, which we call streaming. Okay, so that's the extraction part of things. It needs to load it somewhere, which we call it ELT. So extract, load, and transform. Transform basically means you're able to process that information and basically make it understandable by business users or by the stakeholders. Now, it's also possible that you want to just extract it, transform it, and just load it. So extract the data from this system, transform it, and also load it into a destination where it can become it becomes more understandable by stakeholders. So when we define what a data engineer does, okay, that's the system that I explained, that is building this entire system that makes stakeholders make informed decisions from an app perspective, okay? And most of the things we have right now are basically web applications or mobile applications or all this kind of stuff. Now, but that sounds like, okay, he's built it. Now it needs to be used. It needs to be used well. People need to get trained on it and all of this. So on a high level, what we've just done is we've tried to identify 4 key areas where a data engineer, that can help you really define what a data engineer is. One is data modeling. Okay, when you extract this information, you need to transform it and load it somewhere. You load this into what is called a data warehouse. Okay, a data warehouse needs to be modeled in such a way that it can become the enterprise source of truth. Okay, so an organization needs a source of truth, and that is where that is basically what a data warehouse means. A data warehouse needs to be modeled in such a way that it can scale. Scaling means it can grow over time. I mean, 100 years to come. It must never be deleted. It must never be updated. It must be like your source of truth, where you get the entire data of an application lifespan or an organization lifespan. So that's where the data modeling technique comes in. Basically, you need a data engineer who knows how to design conceptually and logically a data model. You need a data engineer who knows how to build the data pipeline systems, which I just explained initially, who knows how to process the data. So building data workflow systems. How do I process this data in such a way that it's efficient, it's scalable, and this basically means that you understand the right tools to use and when to use them. And of course, the entire data platform. So the entire data platform basically means so it captures everything. So your database, your data warehouse, your login system to monitor what is happening between the ETL, so extract, transform, and load systems. So basically, your data platform is your entire infrastructure. So that's the entire factory, So the doors, the lighting systems, the machineries, so everything, that's your entire data platform. So you really see this dude that we're talking about here, or this lady, whoever it may be, is a person that really captures a lot of skill set, but this is just too big. You have people coming to a data engineer asking, where is the data source from this data? Come on, this guy built this stuff like 6 months or 1 year ago. He cannot remember. That's now you have a data steward who is basically now responsible for governance, lineage, data lineage, and things like this. So the role is so big and it's so in high demand because of huge data explosion that companies did not prepare for. So it's really difficult to pin it down. But what we see is that because it has become one of the most relevant skills or career area in the tech space in the world today, everybody claims they are doing it, which is not the case. Next, we're going to be looking at why a software engineer is not a data engineer. I love this so much, okay? The reason is simple. I think software engineers are great people. Okay, a data engineer is a software engineer. A software engineer is not a data engineer. I hope that is clear. A data engineer is a software engineer because it's building softwares. A software engineer is not a data engineer. So software engineering is part of data engineering. That's basically what it means. But data engineering is not software engineering. So we've highlighted a couple of things, but I will start with one thing that is actually not in this this box that we've created, and that's the size of data. Okay. One of the three major components of data engineering or big data generally is the three V's, which is the volume, the velocity, and the variety of data. What is the volume? The volume talks about the size of data. The velocity talks about the speed of data generation. And the variety talks about the types of data. This is not what software engineers are used to. And I'm 100% sure that they don't even know what we're talking about, okay? And the reason is simple. You have companies that have very small size of data. They really might not really need the industry standard data engineer. What they really need is maybe a data analyst or a software engineer or something that can really, build some systems that they can use to process their data. The moment you start having big data, so what is big data? Big data is data that cannot fit into one single computer system or one simple system, basically. That's what a big data is. The moment it cannot fit into your one single node, a node is basically just one computer system, then it's big data. Now, this is where data engineers come in. They are used to working with distributed systems. What are distributed systems? Distributed systems basically means you have 10 computers and you're using them as one single computer. So behind the scene, there are 10 computers because big data cannot fit into one computer. It needs to fit into several computers. And you as a user, you are seeing it as one computer. So that's why we call them distributed systems. And that's why there's a correlation between distributed systems and big data. And software engineers basically do not work with this kind of data. So on a more lower level, so trying to look directly into what they do on a day-to-day basis, we'll start by looking at the end product. The end product of a data engineer is data. The end product of a software engineer is the application. Okay, so I explained initially saying, okay, you have this app service that has been built. So maybe it's a bank app, a social media app, a supply chain app, a food delivery app, whatever it may be, that's built by a software engineer. Okay, so back-end developers, front-end developers, and all of those guys in that space. But their end product is the app. It's their end product. The end product of a data engineer is the data. As data engineers, we think about how quickly can I deliver data? How quickly can I deliver data? The software engineer is thinking, how quickly can I deliver the app? How quickly can I deliver the app? So the end product is different. The next thing is the end users. The end users of a data engineer are the stakeholders within the data value chain. We discussed the data value chain. I would advise you to please go back to our YouTube videos and watch what we discussed about the data value chain. So the data value chain basically means the processes, the steps that we use to add value to data from point A to point Z. So the stakeholders within this data value chain are our end users, right? Because one data actor completes his work and delivers to the next data actor, to the next data actor. So we in the data space are our stakeholders, to the point whereby even the last person in that value chain is usually the BI developer. Okay, so the business intelligence developer, it's the person that builds the dashboard and whatnot. But this person is also a stakeholder within the data value chain. The end users of the product of a software engineer are the users of the application. We are using Zoom right now. Zoom is an application. So we, the users, are the end users. This was not built by a data engineer. This was built by a software engineer and basically the users. So every person that uses that application is basically the end users of the product built by a software engineer. Next is the value creation. Okay. Data engineers build systems that use data. Software engineers build applications that generate data. You see the difference? The systems built by Zoom right now, Zoom is basically storing, Data2Bots is going to have a 1 hour usage on Saturday morning. They want to understand, why are they using it on Saturday morning? What are they using it for? And all of these questions, they can only answer it by the system that is generating the data, which is the Zoom application. Now, a data engineer, on the other hand, creates value because it builds system that uses the data. Okay, so that system that the data needs to pass through is what data engineer builds. So that's where they create their value. Next is the database systems. For those of you that are not really familiar with what is OLAP and OLTP, OLAP and OLTP, I would explain so it can give you some context. An online analytical processing system basically means a data warehouse. Just see it like that. A data warehouse is a database. Okay, these two things are databases. An OLAP is a system that you basically use to analyze data. So a database that does not have a lot of CRUD operations. CRUD operations, I explained initially, basically means create, read, update, and delete. So as a user comes into an application, he or she creates a username, change password, delete account, deposit money into the bank. So all of these things are creating either create, read, update, and delete, like read and write operations on the database. For an OLAP system, it's a database that does a lot of reads, okay, not a lot of writes. So that's like a data warehouse. So the system that the database system that a data engineer works with is usually the OLAP kind of systems, while the software engineer works with database systems that are OLTPs, because they create the application, and whenever a user needs to perform some kind of actions on that application, it's going in and out. I log in now, I log out tomorrow, the next minute. I change my password now. So you perform operations that basically reads and writes, but a lot of writes in most cases. So they also work with different databases. That's basically the point here. Now, we will be looking at data engineering roadmap. Okay, now that we have a lot of understanding about high-level differences and things like what the data engineer means, we should now look at how can I become this guy? How can I become this lady? What are the challenges? What is the roadmap? I have people asking me this every day. Every day. I myself have basically gone through it so much that I lose track. So it makes sense that we can put it into pen and paper. We can create a roadmap out of it and basically show people what it takes. So in every field, I think there's always beginners, intermediates, and advanced, right? And next, we then have thought leaders, right, in that particular space. So we would limit this, of course, to data engineering. So what do you expect from a beginner in data engineering space? First, he or she should be able to learn the concepts and the basics of data engineering. It's sufficient. It's really sufficient. I can guarantee you that knowing the concepts and the basics is, let's take English language for an example, or any other language as an example, right? Your basics would mean, you know, the alphabets, you know, why we use alphabets, because we use them to generate words and sentences. So you need to understand the basics, the concepts. You need to understand the grammatical related stuff, the kind of, what is a data warehouse, what is OLTP and, you know, OLAP. You need to understand at the minimum the beginner side of a programming language. So the real basic stuff. You really do not need to, you know everything. What is expected of you in this space is the basic stuff. You must be conceptually sound enough to know the basics, such that you can have a nice conversation, and you might still be struggling with a programming language or not. That's fine. So the concept is really important in this field because we use the same concepts. It will be difficult for you to just succeed as a beginner if you don't understand the concept, the way of thinking. That's why even when the software engineers want to come into the space, despite there might be 10 years of programming experience, it really doesn't matter. What matters is we are talking about data, and you need to understand the basics. So we basically retrain their minds such that they can speak like a data engineer. It's like any profession, right? If you're a lawyer and you're trying to be a doctor, you need to know the language of the doctors. Okay, I've been to the hospital several times in my life, like maybe any other person, and you see the doctor's report writing to the nurse. I'm sure most of us don't, we cannot read it because only the nurse really understands. So you should be able to talk to your colleague. So conceptually, you must be good. The basics, you must be fine. Programming, you can still be managed because these are things you can learn along the line. The next thing is at the intermediate level, okay? You must be able to start doing some complex stuff. If the moment you get to the intermediate, you must be able to start doing some complex stuff. What are the complex stuffs? You must be able to understand standards. Standards now make things complex. So what standard is expected of me in a programming language, for example? At that time, you're already improving your programming skills and you're already getting your hands strong on the wheel. So standards now becomes like you don't get forgiven for as a beginner that is still trying to learn concepts and basics. Now you have standard. You must follow standards because you are already an intermediate. At the advanced level, what's expected of you really is you need to be able to build stuff, one, not just standard, but also independent. You must be able to maintain stuff that someone has built. You must be able to improve stuff somebody has built, and you must be able to build them in such a way that they are resilient and they are scalable. Now, we will be looking at this more in depth, okay? So, the beginners, what is expected for a beginner? If you're looking at it more on a kind of really doing level, is he or she must be able to build a simple ELT or ETL pipeline. I described this in a few slides before this. What is an ELT pipeline and what is an ETL pipeline? Talking about extracting data from source systems, loading them into databases, into some kind of storage solution, and transforming them so that it can become usable by stakeholders. ETL basically means you do the transform before you store. So it's really the same thing, but just a different approach. So, but on a more doing level, on hands-on, what is expected is one, I talk about concepts, so you must know data types and their concepts. You must understand what is a structured data, what is a semi-structured data, and what is an unstructured data. So data comes in several forms, right? So structured data could be a CSV file kind of data. It could be an Excel. It could be, so really tabular data. Tabular data is a structured data. A semi-structured data, it's something that it's like JSON. So if you know JSON data, XMLs, so semi-structured. And we have unstructured data, things like video files, pictures, and things like this. So you must be able to understand data types. Data types are things like numeric, Boolean. Boolean is like true or false. Numeric are like numbers. Strings are like text. So you must understand what are data types, what are the kind of structures of data. So you must understand the concept because every day you will be hearing these things. The second thing you want to think about is, now I need to learn how to write code. So you must understand basic SQL concepts and SQL databases and SQL queries. That's always what I think you won't spend so much time doing because you are not supposed to be the perfect SQL writer. You are just supposed to understand it because you are basically moving data from one source to another target, to another destination, and you need to use some SQL queries to validate, so basic SQLs, not like advanced SQL. But you must understand several SQL databases. SQL basically means structured queried language. That's the most common system you find for applications that are OLTPs. Having said that, you move next to your programming concept and specifically in Python. It doesn't have to be Python. So for those that write in other programming languages, don't strangle me. But I always say Python is the best programming language for data engineers. Scala is also a great programming language for data engineers. But the moment you leave these two world of Python and Scala, I start moving towards Java, on Node.js kind of things, I tell you no. You might start thinking of your career path, So I think if you stick to Python and Scala, you will be fine. But those are the kind of programming languages that you need to start getting start learning exactly to the usage and the standards. That's very important. Next is the data warehousing and data modeling. Okay, you remember I also described this when I was talking about what a data engineer is. So you need to understand what is a data warehouse. How can I build one? How can I design one? How do I model it and things like this? Next, you move to networking concepts and connections. Secured file transfer protocol, which we call the SFTP. This is basically when you move a file from one system to another system in a secured way. What are firewalls? What are proxy servers? What is port forwarding? So a little bit of networking. You don't need to, deep dive into it to get yourself crazy. Just know the high-level stuff, like I've mentioned. The next thing is API concept and development. So you must be able to write simple APIs. You will be able to connect to simple APIs, RESTful APIs, and because sometimes you need to serve your data via an API. Sometimes you need to consume your data via an API. What is an API? An API is an application programming interface. It is the way two different services talk to each other. So you have a back-end service, you have a front-end service, and they want to talk to each other. Usually they talk to each other via an API layer. So we'll now look at the intermediate. Okay, the intermediate roadmap is really focused on building data pipelines and applying the things you've learned in your previous beginner state. Because conceptually, you would have learned a lot of stuff on the basic level, at your beginner's level, at your beginner stage, that you need to really apply at this point. At this point, standard is not an option. It must be applied. And what are the things you need to start learning? Software engineering, best practices, and implementation. You start looking at things like Linux, command line, and shell scripting. I've seen beginners who have already picked it up from that point, but at this point, you must be able to interact well with your command line. So there is really no fear of command line at this point. You must be able to basically interact with command line very well. Next thing is your containerization concept and development. What is containerization? So in recent time, we've seen that applications, so softwares are packaged as a container, as a Docker container. So this might be a bit technical for those who are not yet in this level, but it basically means you are making your software deployable. So when you build a software, you need to deploy the software on a machine. So basically what you're doing is you don't want to limit your software to that machine. You want to be able to package your software and ship it without stress. So to ship your software like a package, you need to be able to encapsulate it in something like a Docker container. So you can take your software from today, deploy it in the Netherlands, and tomorrow deploy it on Dami's system, on Joshua's computer, and deploy it anywhere. So Docker is what helps you to package it. So it's like an envelope. Okay, when you go into the post office, you need an envelope to package your letter. Your letter is the software, the envelope is the package. So that package around your software is what we call containerization. The next thing is we talk about data processing frameworks. We have several data processing frameworks, but in this case, you must learn the basic ones, which is basically Pandas, Apache Spark, Apache Beam. And you remember that we've been talking about ETL and ELT. The T part is where you do transformation and processing. And we use several frameworks to do this. And those are the kind of frameworks that you need to really have a hands on. I always tell people, master one first before you start trying to learn the others. Master one first before you start trying to learn the others. So we have several frameworks. Don't get yourself lost. Focus on one, be a master of one. The knowledge you have from one, you can extract it to the other, and you will go far really quickly. The next thing is workflow orchestration and development. I'm sure by now, you see what it means to be an intermediate person. You're already becoming really, really good at what you're doing. And when I ask people, how many years of experience do you have? When they tell me, oh, I have 3 years of experience, I'm like, 3 years of doing the same thing, so just doing one thing, or 3 years of that profession? Because 3 years doesn't mean that you are learning. 3 years could mean you're just going in circles. So you're just on a treadmill. If you're on a treadmill, you can go for 10 kilometers, you're still in the same point. But if you're on the road and you go for 1 kilometer, you're in a different point. So this is the way I see it. So the roadmap shows you all what you need to know to call yourself an intermediate data engineer. Okay, so, and I would expect that someone who is 3 years in a particular data engineer role should have gone through all of the cycles. So the years doesn't really matter if you're doing the same thing. So if you're only learning Linux and maybe containerization and you miss all the other things, you are still a junior, basically. So it's not the amount of years you spend doing these things, it's you basically adding the steps, and you're moving from point A to point B. So what you see here is, okay, you need to learn, of course, things like workflow orchestration, concept and development. What is workflow orchestration? So you have data moving from the database here. It needs to get processed. Maybe there are 4 levels of processing. So processing A, processing B, processing C, transformation D, and all of this. So you need something to basically control this movement. So how is it basically moving from point A to point B? That is what the workflow orchestration does. The next thing you then see is the SQL database concept and implementation. So my bad, I mean SQL, I mean NoSQL, that's what I meant. So the difference between a SQL and a NoSQL database basically means that the SQL is a structured queried language databases, and the NoSQL basically means it's not SQL. So these are like databases that handle semi-structured kind of data. I explained what are structured and semi-structured kind of data. So this is where you have semi-structured kind of data and some other features within the NoSQL databases. So this is always used in the world of big data engineering. Next is the cloud engineering concept. So if you have not been familiar to the cloud, you must be able to know that the cloud engineering, I think we have the slide running fast, but I will, because of time, also just run. So we have the cloud engineering, and we have the what is it? We have the logging and debugging. So you need to be able to monitor your systems. You need to be able to debug your systems. So that's what we have next. So we have the advanced. I would run through this because of time. The advanced basically runs through high-level thinking, and you must be able to design and build cloud data platforms, applying all of the knowledge you've learned. So you remember I talked about data platform as the entire factory. So the machineries, the lighting systems, the doors, the windows, everything. At that point, you must be able to understand what does it take to build a factory, not just the machinery, not just the building, but the factory, So at this point, that's what we call a data platform. At that point, you already start getting to the advanced level. So you must understand. I might have been working as a data engineer using a single interface. So, but behind the scene, I have 10 computers. We call them distributed systems. So you must be able to understand the architecture of distributed systems. You must be able to understand serverless concepts. Serverless concept is basically systems that you do not maintain and do not basically have the infrastructure, the hardware infrastructure. They're really serverless, so they don't have server. It's some of them, we call them like cloud functions or lambdas, for those of you that are familiar with cloud components. Next we have is the container orchestration, things like Kubernetes. Then we have things like message broken system. Then we have data governance concepts. This is really advanced stuff, but you can already see on a high overview that at that point you have a lot of knowledge. Then we will then look next on how will you stand out from other data engineers. In every profession, we see that people get to a point where they feel like, I've really spent a lot of time, I have gone through the roadmap, I have achieved a lot of stuff. How do I stand out? How do I make myself a unique person within this space? Content creation. When you create content, you help people. It's just that simple. This is not marketing. This is helping people. Because if you learn something, you must be able to share. And when you share, you are basically relearning and you're improving what you've learned. Okay, what you learn that you cannot pen down and you cannot distribute via whatever channel, Is it that you're not confident enough that you've learned it? Or you basically haven't really learned it. Or you don't also, and for you to be able to make yourself stand out, people would reach out to you, ask you questions, share your knowledge, create room to explain things to people. As you explain to people, you are understanding better. Okay, write articles, create some public open source project on GitHub. Design architectures and share for people to be able to see those architectures and basically give you feedbacks. So teach what you've known to others. So through the idea of creating content. And I think that also cover the points on knowledge sharing, because when you create the content, you need to distribute it. And I love this. So this is something that I've decided to explain how I think as a data engineer, and to also help other people to be able to think like that. If your data system has to be a great data system, so your data solution, you must be able to think like me. Well, you can also say, how does Dami think? So I think in these 4 areas: is the data consistent? Is the data accurate? Is your solution scalable? Is your data traceable? And is your data system secure? I call it casts. This is a checklist I go through in my head. I don't even have to consciously think about it again, because I've been doing this every day. I just ask myself, how consistent will this data be? Is it reproducible? So not just the code, but the data itself. Is it consistent? Is it delivery consistently? So that consistency must be there in terms of the data solution. The next thing is this really accurate? Okay, is this data accurate? Is it just garbage in, garbage out, or garbage in, transformed, and value out? So you need to think about the accuracy of the data. Then is your solution scalable? So is that your entire platform scalable? If data surge happens, if you have an upsurge in your data, are you able to manage this system? If your database has been built to just manage 10 gigabytes of data, how can it scale without you start panicking? So is the pipeline scalable? Now, are your data sources traceable? Because you can't just deliver data and I ask you tomorrow that we need to build something similar and it's not traceable. So it must be traceable so that you can also build other lookalike systems. And is it secured? Data is money, data is value. How secure is your entire solution? So remember the casts and try to apply this. Now, the final topic would then be, is data engineering career right for me? This speaks for itself, and we've discussed this also a bit in our previous webinars. The first thing is, do I have the right academic background? Do I have the right work experience? Do I have a learning ability? And am I committed? Having said all of this, I think I can come to an end of my presentation, and I would give the floor to Joshua. Thank you.
Well, thank you very much, Dami. This is too much value. So, guys, I want you to actually go into the chats right now. Tell me how valuable this is to you, because this, I have derived a lot. At this point, nobody can tell you you cannot become a data engineer, because all you have to do is go to the Data2Bots Academy YouTube channel, look for that roadmap, follow that roadmap one by one. If you want to be committed, you do that, and by the time you get to that advanced level and you have that project under your belt, you're already doing that. But now the Data2Bots Academy is building a platform that simplifies that whole process for you. And I think it's something to be really, really excited about. And at this time, it's time for Q&A. It's time for us to ask our questions. If you have questions, please shoot them in the chat, and Dami or I would try to answer them as fast as possible, because we just have a little more time. But let me know in the chats how valuable this is, because right now you already have all the resources. Dami has touched on things: advanced, intermediate, beginner. From the beginner, you move to the intermediate, and by that time, you're already learning so many things that at the advanced level, you just begin to apply those things. And I say this because it's like maths. As I'm talking, please let's be putting stuff in our Q&A if you have stuff, and we'll attend to that right now. So as I'm saying, I say this most of the time, mathematics is based on a few operations: addition, subtraction, division, multiplication. And it's on top of that that you have calculus built on top of it. You know that to get the differential of something, they say you take the power, multiply it by the constant, and you subtract one from it. And that is what a differential is. To get the integral, you add 1 to the power and divide it by the constant that you have. It's still based on these basic building blocks of addition, subtraction, multiplication. And that is the same thing with every area or every aspect of life. And we've already put that into data engineering. By the time you learn those basics and you now begin to apply them on a more complex, more skilled level, it doesn't change from those basics. So it's nothing to be scared about. It's nothing to be scared about. And this is tremendous value for you. So guys, please share this to your fellow friends who want to become data engineers. Let them know that there's a difference between working experience and experience working. Everybody has running experience. I've been running now. Anytime you run. So you have running experience. But I don't have experience. I don't have experience running, like doing the stuff day in, day out. So these are the things that we're trying to push out, and Danny has done a very, very good job. So we don't have Q&A, and that just means that everybody you already understand it, because I do understand it, and it shows that we have a very, very attentive listening audience right now. So we are already at the end of this topic, and I'll just like to go in for the next one. Okay, we had one question coming quickly. So Iberichuku is saying that, in our opinion, is it better to start from a data analyst than move to a data engineer?
Thanks, Iberi, for your question. Yes, depending on where you're coming from. So what is your academic background? What experiences have you had in the past? Data engineering is not scary, so don't let it scare you. It's a lot of stuff. I'm not going to, bring it down beyond what it is, below what it is. But the question is, it depends on your where you're coming from. But the answer is yes. It's better to start as a data analyst before moving to a data engineer. But again, it all depends on your background. If you come as a software engineer, if your background is in software engineering, I would say no, because you can already become a data engineer. If your background is in, for example, sociology, psychology, I think data analyst is a good point to start. So you need to know where your background is to decide this kind of stuff. Yeah.
Fantastic. Thank you very much for that, Dami. And we have a very interesting question now. I think this would be the last question that we'll take as we press up with time. It says, Akinwumi is saying, okay, Akinkumi is saying, thank you very much for the presentation. So my questions are, would Apache Kafka be considered intermediate or advanced knowledge? That's one. Two, which cloud platform is more suitable for data engineering out of the big three? I want to take the Apache Kafka one. Do you mind, Adami?
Please proceed, Joshua.
Okay. Apache Kafka would be considered as intermediate knowledge. Now, we are distributing intermediate knowledge from advanced knowledge, as that advanced is where you bring all of these things together. Apache Kafka in itself is what you call an event streaming platform that allows you to get applications, instead of talking directly to one another, talk to a single platform, and you have other applications who want data connect to that platform. So it's intermediate knowledge. So you need a message, broker, like you need the postman in between. Imagine everybody was sending letters to ourselves, right? It will be a whole mess. So we have the post office, and that's Apache Kafka. All the messages go to Apache Kafka. Then me, I go there and collect the message I want from Apache Kafka. So Apache Kafka is intermediate knowledge. And when you learn that, advanced application of how Apache Kafka would now interact within this, a whole broad system, a whole data platform that they're trying to build, is now what you now describe as an advanced knowledge. I hope that answers your question. Number 2 is, which cloud platform is more suitable for data engineering out of the big 3? So that means you want to take that?
Yes, I can. So we have the big 3s, AWS, Azure, and GCP, Google Cloud Platform. Depending on the organizations, so companies ask this every day. So I think this should be a question from a company. So it depends on the organization strategy. All of them are suitable for, equally suitable for data engineering, equally suitable. Now, the organization strategy will determine which platform to go for. So what are the things an organization can consider? One is, do they want to go cloud native, or they want to have a hybrid? A cloud native basically means 100% of everything goes to the cloud, or they still want to maintain their on-prem and their cloud solution. Another thing that they can use to determine is cost. How much is this company willing to invest in cloud solution? The cost has a huge impact. Another thing is the size of data. We said which is more suitable for data engineering, but data engineering is a field, but we have the size of the data. The bigger the data, then you can then decide, okay, which cloud platform should I go for? Because it can also be relative to cost. Any cloud platform can manage the size of the data, but some cloud has cheaper cost in terms of storage. So this is more on an organizational level, and I don't think any data engineer would actually, in my opinion, be making this kind of decisions. These decisions are made by at a high level within an organization. But to answer your question, they are all equally suitable for data engineering.
Yeah, thank you very much, Dami. And to just add to that, as a data engineer, your aim is to be data agnostic. So to be cloud agnostic. So whether AWS, GCP, Azure, once you have those concepts, you can actually go there and apply those things. As Damia said, it's all suitable. It depends on the organizational needs. So that's it for the Q&A session. Now we have our next webinar. We are going to be talking on the analytics engineer. We have talked about the data engineer now, and we're now talking about the analytics engineer. And this is another interesting one because in Nigeria, they expect you to be the data engineer, the analytics engineer, the machine learning engineer, and they just brand it, oh, be the data scientist or the data analyst. No, we're going to debunk all of that. So come next week, invite your guys and know the industry standard. Come and just understand the industry standard. And on the 30th, same time, Zoom, our registration links would be on all our social media platforms. So you can just go there, register, share that with your friends. And yeah, if you want to make reference to this, it's going to be on our YouTube channel, and you can just go there, make reference to it. I think it's high value stuff, and you would answer your questions. Like, so you stop wasting time on being a jack of all trades, master of none, and being a master of one and giving value to where you're supposed to give value in the data value chain. With that said, I want to say thank you for joining. Somebody says you can't wait for July. Yeah, we can't wait for July also. Thank you for joining the Data2Bots Academy webinar, and we hope to see you in the next one. Bye.
Bye.